For physics GCSE, you need to know what a system is, so remember this. A system is an object or a group of objects, and we use systems as a way of demonstrating key physics principles, mainly around what happens to energy and how it's conserved, and what happens to forces and what happens to things like momentum. So what we're going to do is give you some examples here of systems, and you can see what the whole principle of this is. First of all, let's consider someone playing a game of rugby or American football, and they kick the ball a long way up and it lands some distance away. Initially, once the ball has left the boot, it's got a lot of kinetic energy, a little bit of gravitational potential energy, and as it increases in height to get to its maximum height, it will have very little kinetic energy there and a maximum amount of gravitational potential energy. The kinetic energy it'll have would be because it's just moving forward in this diagram. Then, of course, as it begins to fall down to Earth, it gains speed, so the gravitational potential energy is changed into kinetic energy. And just before it's about to hit the ground, it's got maximum kinetic energy, a tiny, in fact, just tiny amount of gravitational potential energy. And then let's pretend that the ball hits the ground and it doesn't bounce. Then at that point, all of the kinetic energy has been turned into heat and sound energy. What is important to know is that the amount of energy you started with as the ball was kicked has been preserved or conserved, so that the total amount of energy you put in the ball at the beginning is equal to the amount of heat and sound energy you got out at the end. Another example of a system which we'll investigate as part of the GCSE, we'll be looking at collisions of cars. So here, for example, we've got cars with kinetic energy moving in towards each other, and then what you'll find is that kinetic energy is then changed into heat energy and sound energy as well. It'll also be changed to elastic energy stored in bits of deformed metal as well. If we look at another example of a system, we could consider the heat transfers involved in a kettle. The electrical energy is delivered to the kettle transfers this in the form of heat. Most of the heat goes into the water to heat it up, but some does escape, and there is of course a bit of sound energy as well involved. Now, if we look at the heat energy that's escaped into the air, the wasted energy, and add that to the thermal energy and sound energy, you will find that that will equal the total energy supplied by the kettle in that system. So the key things to learn here are that energy is measured in joules. Energy cannot be created nor destroyed. This is known as the law of conservation of energy. Energy can be changed into other forms. Okay, it can be changed into one type or another. Whatever you do, never say energy is used. That is a schoolboy error, a schoolgirl error, and it is always transferred. Energy is transferred. It is never ever used. You need to know there's different types of energy. So there's potential energy or stored energy, and these include chemical potential energy, gravitational potential energy, and elastic potential energy. As part of the course, you will have to memorize the formula for gravitational potential energy. You'll have to use the formula for elastic potential energy, and you will also have to use the formula for kinetic energy, which is in the next column. And these are types of energy that are moving. So kinetic energy moves, light energy is moving, sound energy is moving, heat is moving, and so is electrical energy. The formulas for kinetic energy, elastic potential energy, and gravitational potential energy will be in another video. You just have to learn and remember gravitational potential energy and kinetic energy formulas, but I'll give you those later.